This is CPM Calculus, Chapter 3, number 180. Let f be the function given by f of x equals x cubed minus 3x squared minus 24x plus k, where k is a constant. Okay? On what intervals is f increasing? All right. So this is a really good problem. All right. We know what this kind of looks like. It's a cubic function, right? But can we graph it? So first of all, can we graph this? Graph? You might think no because we don't know what k is. But what is k? If it's a constant, all k is going to do is shift, right? This is going to shift the function up or down, right? It doesn't really change the behavior. It just shifts it vertically up or down, whatever k is. If k is 5, we shift the whole thing up 5 units. If k is negative 20, we shift the whole thing down 20 units, right? So graph, yes, we can. Just ignore k. You don't even need to put the k in there because the intervals where it's increasing is not dependent on whether or not we shift the graph up or down. But let's solve this one algebraically because we can do it graphically kind of easy with our calculator. So what do we know when f is increasing? We know this is the same thing as f prime of x is greater than 0, right? Wherever f is increasing, then the derivative function is positive, right? It's going to be above the x-axis. So let's look at the derivative function. F prime of x is equal to, using the power rule, it's equal to 3x squared minus 6x minus 24, right? Just using the power rule. Since this is a k, it's going to become 0, right? It's a constant, so I don't even need to write it. All right, excuse me. So now we have this. Well, where is this increasing? Blah. Where is this greater than 0, right? Because this is our derivative function, our slope function. Where is it greater than 0? Well, we know where it's greater than 0. We can graph this, right? Again, we can graph this. That's option 2. So using graphs, right, we can go ahead and graph f of x, and we can look, well, where is it increasing? That's kind of easy. We just see where is it going from down to up, right? Also, we can graph f prime of x and see, well, where is it above the x-axis? So we can graph this one too. Yes, again. Okay, but let's do it algebraically because, again, those are going to be really fast, easy ways to look at a graph and just say, well, it's going to be above the axis in this region. So how can we do it? Well, we know that let's find out first of all where it's equal to 0, right? So we know f prime of x equals to 0 at some points, right? This can have up to 2 different places where it crosses the x-axis. So f prime of x equals to 0 means this whole thing equals to 0. 3x squared minus 6x minus 24, right? So what we can do is factor out a 3, x squared minus 2x minus 8, right? And that's equal to 0. Divide both sides by 3. That quickly gets rid of that 3 because 0 divided by 3 is 0. So we have 0 is equal to x squared minus 2x minus 8. Now is where we can factor this, or we can use the quadratic equation, right? Either way, the quadratic formula, with a being 1, b being negative 2, and c being negative 8. But let's go ahead and factor it. So I'm going to use the x method. We want numbers that add together to get negative 8, and multiply together to get negative 8, and add together to get negative 2. Okay? So what numbers can we multiply to get negative 8? Well, negative 4 and positive 2, right? If you add these, they become negative 2. So this 0 again is equal to, let's factor this, is x minus 4 from here and x plus 2 from here, right? Because this is plus 2 and minus 4. Alright, so then we can separate this since we multiply these two terms and equals to 0. You can say x minus 4 equals to 0, or x plus 2 is equal to 0. And that tells us x is equal to 4 when we add 4 to both sides, or x is equal to negative 2 when we subtract 2 from both sides. Alright, so what can we do now? Well, we know our function, what was the name of our function? Sorry, f of x. No, we're looking at f prime of x, right? So we know f prime of x is going to cross the x-axis at negative 2 and at 4, right? It has an intercept here, so it has a 0. So between negative 2 and 4, it's either above or below, right? We don't know which one yet. It's either above or below. If it's above, that means it's positive, and that means f of x is increasing. If it's below, that means f prime of x is negative, and therefore f of x is decreasing, right? To the left of 2, again, we know it's either above, meaning f of x is increasing if it's positive, or below, that means f of x is decreasing, right? So let's check points. Let's check some point here, any point left of negative 2. Okay, let's check a point, any point between negative 2 and negative 4. I'm going to check 0, negative 3, and let's check a point greater than 4, 5. So at x is equal to negative 3, f prime of x is equal to what? Well, go ahead and plug it in, f prime of x. So it's going to be 3 times negative 3 squared minus 6 times negative 3 minus 24, right? Negative 3 squared is positive 9. 9 times 3 is 27. Negative 6, again, because it's minus 6, times negative 3 means plus 18 minus 24, okay? So we add these together. 27 minus 24 is going to be 3. 18 plus 3 is 21. That's saying over here on the left side, f prime of x is what? It's positive. So I'm going to, over here, I'm going to say it's positive over here, f prime of x, right? What does that tell us about f of x? Well, if f prime of x is positive, that means f of x is increasing on this region, right? And let's look at in between. At x is equal to 0, f prime of x is equal to what? 3 times, I'm looking at f of x, 3x squared minus 6x minus 24. 3 times 0 squared minus 6 times 0 minus 24. This is 0, this is 0, just negative 24. That means between negative 2 and 4, everywhere it's negative, right? And therefore, that's telling us f of x is decreasing. All right? So our last point to check is to the right of 4, I'm going to check x is 5. So when x is 5, f prime of x is equal to 3 times 5 squared minus 6 times 5 minus 24. Okay? 5 squared is 25. 25 times 3 is 75. Minus 6 times 5 is 30. Minus 24. Right? 30 and 24 are both negatives. So when you add those together, it's just 75 minus 54. I already know that this is going to be positive now. Right? 75 minus 54 is 21. Positive again. Right? So now I know that over here on the region to the right of 4, it is going to be positive, and that means if f prime of x is positive, that means f of x is increasing again. Alright, so the question is asking us on what intervals is f of x increasing? Well, at x equals to negative 2, we hit a 0 here, and x equals to 4, we hit a 0, but to the right, it's increasing, and to the left of that, it's increasing, right? So given this information, I can go ahead and answer the question and say f of x increasing, and the regions are from negative infinity to negative 2, union, like, or, right, 4 to infinity. Okay? So this is how you do it algebraically. Again, if we had our calculator out, we could have looked at the graph of f of x, excluding, again, k, because that's just shifting it up and down. We could have looked at it and said, well, where is it increasing or decreasing? Or we could have looked at the graph of f prime of x, right, and said, well, where is it above the x-axis? That is going to tell us where it is, where f of x is increasing. All right, so that ends right here. Let's box our answer, and that will end for us CPM Calculus, chapter 3, number 180.